Well, it's been a long time since I made a video. Hopefully we can still remember how to do this. But I got a project which I thought some people would find interesting. We're working on a 1921 Fordson tractor for the local farm museum. Problem with this tractor is they're estimating it probably hasn't run in 20 or 30 years, but over the last 20 or 30 years when it's been sitting around the farm museum, people have, cranked on the starter crank. It's a hand start tractor, and as it has been run over the years, all the valves got stuck open. So I've taken on the job of getting this tractor running again. I have to replace all the, I pulled the head off to start with. All the valve seats are rusted, so I'm going to have to recut all the valve seats. It's a flathead tractor. I've talked to the farm museum about some of these valves. 6 of the 8 valves were the original style valves. Since this is a 1921 tractor, this is actually a 2-piece valve, where it's got a steel valve stem and a cast iron head on it. Problem with these is as they get older, like this one, sometimes the heads will pop off and go floating around in your combustion chamber, which you could imagine is not a good situation to be in. So I've convinced them to let me put all new valves in it. These early valves too were held in place with this. The spring retainer here was held in with a pin keeper to hold the valve spring in there. They did have a couple of the valves were replacements. So this is a newer replacement. So this is a 1-piece valve, and it's got a notch in it for the keepers instead of a pinhole. But might as well just change them all instead of changing 6 of the valves and leaving 2 of these in there. Might as well just change all 6 of them and have all 8 of them and have 8 fresh new valves. So I was able to source some new valves from the Fordson house up in Escanaba, and the spring retainers needed for these valves, but they didn't have any keepers. The valve keepers or valve spring locks, call them by a couple of different names. Problem compared to a modern day like automotive lock, this groove is smaller. Sometimes it's a square groove like this, or sometimes it's a round groove. And there's usually a key that fits in there. And this key is what locks it in place. Well, in this style, the whole keeper sits in here, and these keepers cannot be located. So we'll make a set. Okay, well, we're back. So I haven't shot a video in a while, so I got the first thing to shooting videos, make sure your batteries are charged. Well, I didn't charge my camera long enough, and it quit on me. So I did this on one of my earlier videos, and I plugged the camera into AC power, and I had a 60 hertz buzz in the video. So I got this job set up now, and I need to run it, and I don't want to take the few hours to charge this camera. So I'm hoping there's no hum in this video, but I do apologize if there is. So where was I was at? So we were talking about making valve keepers or valve locks for these valves. Luckily, a couple of these valves were replaced already when I got it, so I was able to had some of the original valve keepers here I was able to measure those and figure them out. Checked them with my hardness files, which I can only check above 40 Rockwell and above with the hardness files, but it was softer than 40, so I don't think they're hardened. I seen a video once a couple of years ago, I think it was by Paul Brody. He made a set of valve keepers for one of his vintage motorcycle engines that he was working on, and works for a vintage motorcycle engine. It'll work for this old tractor. Not using the same exact steel that he was using. I'm going to use some 4140. It's very similar to what he was using, but according to my my books there, that 4140 is pretty shock resistant. So I think it'll be okay for these keepers. I've already made up a set and made sure that they'll work, and I've got to make a couple more sets and show you how that goes. Okay, we're over here on the Monarch lathe. As I mentioned, this is a piece of 4140. The largest diameter on these valve keepers is going to be right around 410 thousandths of an inch. So I've got some 7/16 in here, 7/16 round stock. I can see there's a little center left in here from, this isn't the first piece I made on here. So what I'll do is I'm going to rough turn this outside down, get a little closer to final size. I'm not going to bring it right down to final size. Then I'll drill and ream a 1/4 inch hole in the middle. 1/4 inch is the smaller diameter in that groove on those valves. And then I'll take a final pass on the outside, just make sure everything's concentric. And then we'll put a 6-degree taper in this. That's another difference, is a lot of newer valves are either 10 degrees for automotive valves or for high performance, or 7 degrees for more standard valves. But this is a 6-degree, as I measured a couple of the original locks that I had with keepers, and they all seem to be right around 6 degrees. So they also need to be 320 thousandths maximum length, maybe a little shorter. Length isn't real critical, as long as it fits inside the groove, and it'll work. So I set my stop for about 400 thousandths. That'll give me some room to cut these off when we're done. I'm going to start by taking about 15 thou off there, just to get it close. Get everything roughed in to start with before you start finalizing things. That way nothing moves. I don't know if it doesn't really matter for this so much, but it's good practice. Bring our tailstock in here. Try to get you a little better view there. Things aren't so congested. Grab my cutting oil. Normally don't work so congested. I'm trying to keep the camera in there where you guys can see something. I like to think these center drills fairly gentle, that way they kind of hold the center instead of getting pulled one way or another. That should be good enough. That might be kind of hard to see because there was already a little bit of a center there from before. I'll swap this out to a drill for a 1/4" reamer. 1/64 smaller is kind of the rule of thumb. So this, instead this part's going to be about 320 thousandths long. I'm going to drill this a 1/2 inch just to make sure that we've got lots of room for the reamer to go through and finish the whole part. That drill moved a little bit. Probably the existing bore wasn't quite, probably not quite in the chuck the same way it was last time, but it'll be okay for what we're doing here. There's a 1/2 inch. I'll back this out one more time. Put the 1/4 inch reamer in. So make sure we don't have any chips from the last time we used this reamer in there. And quite a bit of oil. Turn this down. RPM down. Lock tailstock. Just a 1/2 inch, so I'm just going to do the full, just do the full depth in one shot without backing out and clearing chips. There's the bottom. See that reamer flexed a little going in there. Should flow fine. So now we've got a round 1/4 inch hole in the middle. You see that's 0.418, which is fairly close to the 410 size we want to finish with. What I'll do is I'm going to take that down. We'll take it down another 5 thousandths. And when I do the taper, we'll do the taper to the final size. There's that. Get 5 thou. Let's put our RPMs back up. Up to the hard stop. Trying to trip over this tripod I got sitting here. So I've already got my compound on the top here set to the 6 degrees required. So what I'll do is I'll start cutting this. You guys really can't see that well, can you? So I'm trying to get it where you can see something in this camera tripod isn't too much in my way. I might have to hang something from the ceiling. So we want to. So this I want to keep this outside diameter here between say 405 and 410. So you see I'm fairly close there, 412. So what I'm going to do is I'm just going to sneak up on this. I'm going to use my black Sharpie here. I'm going to mark the high end of the part, the high end of the taper. And basically, I just want to cut this taper until that cleans up. That'll be accurate enough for what we're doing here. And I'll lock my longitudinal slide here in place. Hold the touch again. So now I'll back my top slide off. It's set on 6 degrees. Just from past experience, I'm going to start at a 50 thousandths cut. Just to start in the rough shape of this taper in here. No power feed on the top side here. Just take that to that shoulder. Now I can put my cutter up here, and as I advance in, if I touch that, then I know that I'm nearing the finish. We'll take 10th out here. 5, 10, it's not touching yet. See, it's getting close. Slowly advance this in. There we got a line on the black marker. Okay, I'm going to leave that just a couple of thou large. See, I didn't quite clean up the marker on that because I just want to take this emery cloth. It doesn't need to be completely smooth surface, just take a little bit of tool marks out of there, just so it sets where it needs to be. So that's all the turning on here. So this is the basically what it'll look like in the engine, plus a couple of notches. So go over to the bridge port where I've already got that all set up, and we'll cut these two pieces in half over there. Okay, here we are over at the bridge port. I've got this set up from the previous prototype part I made. So this is a ER32 collet block that I've put in here, so I can take these round stocks, put them in here. So that's a 7/16 collet in there. The nice thing about making multiple pieces like this is the slitting saw is already set up to the center line of this collet chuck, so I don't have to reset the height each time I put a different piece in here. What I do need to do is I need to find the face of this part. So it's not a real critical dimension, so what I'll do is I'm just gonna mark it up there. I'm gonna bring the sliding saw in just a touch. Let me go get the phase converter started. Slitting saws, you're going to need some oil for these, cutting off these slitting saws. So what I'm going to do is just feed this in. I'm going to do it without getting away the camera here, just until I hear it touch the face of that part. There, you hear it there. Maybe it's a little too much. It's okay, I got two faces to find it on, so I'll go to the other face. Try to be a little more gentle this time. There, I don't know if you heard it, but it just touched right there. So I'll set my digital readout on the x-axis to 0. 320 is the max size of this. It can be quite a bit shorter. The size doesn't matter because it all pushes up in the slot against this face. I should have mentioned it before. That's why I put this part in this orientation on here, so I can face off this shoulder, this face here, because this face is going to take all the pressure. And the other face is going to be clearance and not really matter as long as it's small enough to fit in the slot. So we'll run the x-axis in 315 thousandths, so we're 5 thou short of the maximum size. Last one I made right at 320, and it was a little tight in there. The corners of that groove aren't quite sharp, and I had to do a lot of hand fitting there. So this is a high speed steel cutter here. With lots of oil. Slitting saws on a feed rather slow, and see, instead of this would be climb cutting if it was a mill. So that's how you run the slitting saw. It really doesn't matter a whole lot, but it's kind of it seems to give you a little better results. Climb cutting with a slitting saw will, where on a manual mill like this, you would normally conventional cut with a mill. So we'll cut through here, put lots of oil on it. It'll be real easy when I first start, at least until I get the groove established and that saw blade gets stabilized in its own groove that it's cutting. Then I can feed it a little bit harder, but it's a high-speed cutter, and this is a Amazon cutter too, so it works, but I don't know how long it's going to last, so we want to be gentle on it. Keep it well oiled. Start to feed to the other side. I keep both parts of the cut lubed enough. If this is a name brand cutter or a carbide cutter, I'd be feeding it a little harder, but I need this cutter to last for a few more parts. And it didn't cost me a lot, but still cost me something. Can't look at the camera on this. Hopefully you guys can see it in the sticking this oil can right in the way where you need to see. And the high part of the cutter is just coming through. there's that. Cut her out of the way. Shut the phase converter off so you can hear me. Like I said, the advantage of this ER32 collet is I can just break this free out of here. And there we've got the piece nearly completed. But now I can go turn more of these up. What I'll probably do is I got to make a couple more of these. So once I clean this off, I'll turn this, flip it over, turn the same thing over here, so I can just come in one. And I just come over here, cut this, flip this around in the block, cut this again. But as I said, the length doesn't really matter a whole lot on here. I mean, you can't be so short that it's going to cause the assembly to be weak. But you know, even if it's got say 10, 15 thou clearance in the slot, it doesn't matter because it's all pushed with spring pressure up in the bottom. And so since the length's not real critical, I'm going to take this over to the bandsaw and cut this off by hand. You had to excuse my mess on the bench over here. I haven't had a chance to clean this bench up yet. Moving around a bunch of stuff and getting ready for a new machine to come in, so I've been reorganizing a lot of things, and the benches are a mess, but that'll be for another video. So this is my Milwaukee bandsaw, handheld bandsaw, and I've got it in this this table, and it's quite handy for cutting off things like this. Let's get this camera set up. So I'm just gonna eyeball this, cut this off at the bottom of the slot that I cut in here. I'll probably cut one side, flip it, and cut the other side. I'll try to keep my hands out of the way, but I don't know. I'm probably gonna get in here and you won't be able to see much, but we'll see. See how it goes. There's one. Cut them from the outside in just to keep the burrs on the more manageable pieces. And real gentle. Don't want them to go flying across the room, so there they are. So I'll take these over, and got a lot of hand filing. I'll go and I'll break all the sharp corners, take all the burrs off them. I want to put some slight chamfers on all the corners so it doesn't cause issues of seating on the valve stem or in the spring retainer either. Okay, so they're all went through and with a file, broke all the edges, took all the burrs off. I don't want to make sure there's no burrs on the inner diameter to keep it from seating properly in this groove. So this is a 5/16 diameter valve, and that's 1/4 inch diameter on that groove. So that's why we drilled and re-missed a 1/4 inch. I also cleaned and broke all the edges on the taper side of it to keep this spring retainer from binding up. You see this, so well, this would go, being a flathead, this would go in the block, and the spring would get put on here with this spring retainer, and the valve spring compressor would hold it up into place. So I put these locks on, these keepers. These two paths go in here. There's a slight gap between them that was sized off the original ones I had, and you can see they're a pretty good fit. basically hanging on by themselves. They're not, there's clearance on the length of them, so that's just the ring fit of the inner diameter grabbing the 1/4 inch of that groove there. So like I was saying, that's a 40 thou. Actually, it's a 39 thou because I use the 1 mil slitting saw gap in there. Measuring the originals on the original valve, they had about a 50 thou, so it's going to work. So this goes up in here. If I can coordinate this, so. And then the taper on the valve spring retainer goes up against these valve spring keepers, and it locks them all together. You can see until the taper is good, because there's no rock in this. So I know it's hard to see on there, but try to keep center. There's no rock in this, and it self-supports. You know, that taper is locked together, so it's holding its own weight. So that tells me that the angle on that is pretty good. Plus this distance from the end of here to the end of this valve is pretty close to what the original ones are. The original valve's got some wear in them, but this might actually be a little bit bigger, but that'll work. Don't have any keyway showing up here, so we know the whole pair of valve locks are inside there. So I hope you found this video interesting, and again, if there was noise in this video, I'll try to filter it out, but we'll see. And if there is still some noise, I apologize for that. I'm not charging my camera, but maybe that's, if I start making more videos on a regular basis, maybe that's one of the things I'll do, is invest in a better camera. So I hope you enjoyed this, and I hope you find it useful. Seeing that I had to reverse engineer these, I might make a drawing of these and put them up on one of the online forums, maybe like smokestack.com or something like that, just so it's out on the internet, so somebody can access in the future, and they don't have to do all the reverse engineering and make prototypes like I did, just to verify that it works. And we'll see you next time.